4-5 videos, last 4-5 videos, extensively on functions. There is an interesting phenomena. In most of the programming languages it is available, yet it started in C program. Previous programs, programming languages which were developed prior to C, they did not have this facility. This facility, now we are discussing today, it started from C and of course it is continued for most of the rest of the programming languages. So this is called recursion. Of course, if you are a computer science student, you will be using this recursion in your later semesters extensively. Whereas if you are a new student to this particular programming language, you are a novice student, then understanding this recursion at some primitive level may be sufficient. This is a special case of programming language. Programming language and of course specifically with the functions. We have seen functions. A function calls another function. This is called calling function. The function which is being called is called called function. You can pass some parameters to this. This can return something to this. All these things, combinations we have seen. Whereas recursion is a special case. Recursion is a function calls itself. Some instances it appears that actually you will have a similar type of work to be carried out regularly. Instead of being called from a calling function, you can call a specific function by itself. Then first question that arises to all of us is, when a function is calling this repeatedly, there should be a way of coming out, because this calls that and it comes back and it calls, it keeps on doing this. There must be a way of coming out of the main function, coming out of the calling function. So this is very, very crucial in case of recursive function. So recursive function is a function called by itself. Okay, we will see that how does this goes. As usual, when you call a function, you will be passing some parameter, and that parameter is being used inside the function, and in between some statements you can call the same function there itself. So therefore, if you call the same program so many number of times, there are every chances that this may go for infinite loop. So to avoid that, you should be very, very careful in how to come out of this. Some point of time you should come out of this. So that is why you should give a logic very, very clearly, algorithm very meticulously planned such a way that this calling by itself should be terminated at certain point of time. Right? How to take this case? Let us take a small case. Say for example, factorial of a number is a usual example that any textbook, any website, if you type for recursion, it takes you to factorial. So therefore, I will also explain the factorial. What is that? Factorial of a number, let us say 10 factorial. 10 factorial can be considered as 10 into 9 factorial. 9 factorial can be considered as 9 into 8 factorial. So 8 factorial equal to 8 into 7 factorial. It keeps on going like this. When let us say 2 factorial. What is 2 factorial? 2 into 1. So 2 into 1 factorial. 2 into 1 factorial. So you go to 1 factorial. So 1 factorial, when a number reaches 1, I am not going further. So therefore I am coming out. So it stops at this point. So therefore every recursion should have a mechanism to come out. Otherwise it becomes an infinite loop. Right? So what I have done in today's today's session is, I have written a program. See, recursion function it is just like a function only, but you are calling inside the same function itself actually. But every recursive function, how do I understand this recursive function? A function inside that, in any function inside that, the same function is called again, right? The same function is called again. Then it becomes a recursive. But when you write a recursive program, a function, as I have already told you, you should be able to a terminal program, right? Now let us see this same program. This factorial of a number, we will see that. Now you see, I have written one main function. You can see in this main function, here there is a main which is gone out of the screen. Okay, now you can see. Okay, I have written the main function. One main function. Clear screen. Printf, please enter your choice. Now, I have explained to you in one of the videos, factorial of a number can be obtained by using a function. The same program I have written it here, and the same logic, the same result I wanted to get it through recursion also. You can get without recursion also, you can do with recursion also. So in both the cases I have explained in this program. So would you like to do a normal factorial? So this we have already seen in earlier videos. Would you like to do the recursion factorial? Alright? You would like to exit. Right? So therefore you are reading this. Right? So you will be reading this option and you will be using a switch statement options. So case 1, normal fact. So I am calling a function called normal fact if it is a case of 1. 1 means you are going for a factorial finding by using a normal method without recursion. Second option, if you are pressing 2, then you are going for recursive factorial. Factorial finding through a recursive mechanism. This is another function I have written. This already I had explained in one of my earlier videos. Case 3 is exit. Only to ensure that actually the same result can be obtained, this program is demonstrated to you to understand the same result you can obtain either by using a conventional function or by using a recursive function. You should get the same result. But you should see the beauty of using this. Alright. Now I am calling two functions called normal fact. In case if you are pressing 1, I am calling a recursive factorial. This I need to explain to you in detail about this in today's video. Recursive factorial is another function that I am supposed to get two functions. One normal factorial and recursive factorial. Normal factorial, this I had already written, but anyway I am explaining to you. You can see from this. So normal fact, I am taking a number from the input. As usual, I am taking one variable called sum, which is equal to 1, and I am using one local variable called I, only for to use it in for loops. So printf, please enter a number. For which number you would like to find the factorial? Let us say 5. 5 factorial is 120. 6 factorial is 720. Like that I should get. So therefore this should be equals. So because I need to do this n number of times. That is number of times. So I plus plus. Sum is equal to sum plus I. So this I had explained earlier. I am not explaining this in detail. So sum initially it is 1. So 1 into 1. Next time 1 into 2 I becomes 2. Next time 1 into 2 into 3. Next time 1 into 2 into 3 into 4. Like this till you what number you wanted. Till then it goes on. Then finally the result will be there in sum. So therefore printf the factorial of this number is sum. So I am printing these two and I am coming out to this function. Similarly, the same result factorial, finding factorial can be obtained by using a recursive function, right? How does this recursive function works, right? We will see this. Int number, take the sum, printf, please enter the number. So you will be entering the number and you will be reading this. What I am doing is, I am calling a function called fact. Factorial is a number, factorial is a function which is written here. This itself is called in the main function. In the main function this is called. Here inside this is calling fact. So I am calling a function called fact which is accepting a variable called number. What is a number value? What is the value that you have typed? 5 or 6 or 7 or 8, 9, 10, whatever you wanted. So that number is here. So that number is passed as a parameter to this function. Then print factorial. Finally, after once we execute this function, then we will be printing the result like this. But this is called recursive. This is the recursive part. This function is the recursive part. What is that? See, I am coming here. Fact. Fact is a function which is returning an integer. Obviously, because it is assigned to sum. Sum is an integer, so therefore it is returning an integer. So therefore int type. Since you are sending a value, I have explained in the last class, pass by value. So it is sending a value. What value? A value which is available in number. So therefore this number is passed. So therefore I am taking it to a local variable called n. N is a local variable in this function which takes the value as like number. So therefore if you have pressed 5, then 5. So here it is. If n equals to 1, is that n value equals to 1? Right now, no. Return 1. Please return a value called 1. Else, return n into, what is the value of n now? N is 5. 5 into factorial of n minus 1. Fact of n minus 1. What is n value? N is 5. So therefore, 5 into, it is as good as, what is 5 factorial? 5 factorial is nothing but 5 into 4 factorial. What is 4 factorial? 4 factorial is nothing but 4 into 3 factorial. Like this, n is 5. So 5 into fact of n minus 1. N is 5, so therefore n minus 1 is 4. So therefore 5 into fact of 4. Factorial of 4. I am calling the same function here. Now with a different value. It's a different value. Earlier, this value is passed. Now I am passing this value. When you do the same program again, what is this? Now, with respect to this fact of n minus 1, it is coming here. It is returning an integer and it accepts a number called n. What is its n value now? N value is now 4. Is n equals to 1? No. Else return n into, what is n value? N is nothing but 4 into fact of 3. So therefore n into fact of 3. So like this it keeps on doing till you get 1. Once it reaches 1, it returns 1 and it passes to the next calling time. So many instances are created, so many Xerox copies are created. You can understand something like this actually. Each time a Xerox copy is created, from this it is passed to this to this, this to this, this to this. Ultimately the result will be stored in some value and that is returned to this sum. So when you run this program, you will appreciate this program runs successfully. So here I am asking the user, please enter your choice. Would you like to go for a normal factorial or would you like to get a recursive factorial? So I will press 1. Please enter the number. I will enter 5. What is a 5 factorial? 5 factorial is 120. This we had seen earlier already. You press any button. Again you press 6. 6 factorial is 720. You press 1. 8. 8 factorial is too big, so that is why it is coming out with some negative number. You go with let us say 7. 1. Then 7. 7 factorial is 5040. Right? So 5040. Like this. It has got. Now, I would like to go for recursion factorial. I will press 2. I will press 2. When you press 2, it asks for a number. What is the number? Again, I try with 5. The factorial of 5 is 120. It gets the value. Now, I am getting the same result. Either through a normal factorial method or through the recursive factorial method. Right? You can try with another options. So, please enter the number 4. So, 4 factorial is 24. So, when you press 2, it goes to recursive mechanism. When you press 1, it goes for a normal factorial, normal function mechanism. So, this is how, when you press 3, it comes out. You can see again, recursive function. So, this function is being called when you press 2. Interestingly, you should not worry about other aspect, you should worry about how to call the same function with a repeated thing. And if you are new to any programming language, writing recursive is slightly complicated. It requires little bit of exercise. It requires little bit of knowledge. It requires a little bit of expertise. You need to convert your thinking, your logic into a mechanism of recursion, so that requires little bit of expertise. Alright. Anyway, this is there in the syllabus, so therefore I am supposed to explain to you. Similarly, the same recursion can be used for many other applications. So I have done one more application which is very popular. This is called Fibonacci. This Fibonacci series is again can be implemented without recursion and can be implemented with recursion. I have demonstrated here with the recursion. What is this? Basically, the Fibonacci series is a series that you get. It is addition of previous two numbers, but the first two numbers are to be fixed. It is 0 and 1. The first two numbers in the series are 0 and 1. Next is addition of previous two numbers. 0 plus 1 is 1. Next, previous two numbers are 1 plus 1, that becomes 2. Next, 1 plus 2, that becomes 3. Then 3 plus 2, that becomes 5. It means first two numbers always it is 0 and 1. The next number is nothing but addition of previous two numbers. So this is called Fibonacci series. In fact, this Fibonacci series has got lot of applications. In any one of the videos, I may be explaining that. Actually, right now I don't have time to explain how this is relevant to our engineering applications, daily life science applications, etc. and all. It has got a lot of applications. Now I am not going into that actually. But you should understand that Fibonacci series is a series it generated by means of adding previous two numbers. It has got lot of characteristics by itself. Let's not get into the characteristic, right? How does this behave? How does this can be calculated? I am using one C program, right? C program here with a recursion to identify the Fibonacci number. How? say for example, please enter the number of term in the series. Say for example, I would like to have 10 numbers series. So first two numbers are always fixed, it is 0 and 1. The next number is addition of previous two, that is 0 and 1, that becomes 1. Next number is addition of previous two number, it is 1 plus 1, that becomes 2. Next number is 2 plus 1, that becomes 3. So like this, you keep on adding previous two numbers and generate the next number. So I am generating 10th number or 15th number or 20th number. How many numbers you want? So that you have to enter over here. Please enter the number of terms in the series. Alright, you may be entering 10. So it will be generating 10 Fibonacci numbers. Understand? First two numbers are 0 and 1. Right? So you are reading the number. For I equal to 0 to less than n, it means 10 number of times I am just doing this. So result is equal to, I am calling a function called fib. Fib is a function I am calling here. I am passing a parameter called I. I am now passing a parameter called I and I am sending it to that. So print the result. Alright. How does this works? Fib, how does it works? You can see from here. Fib is a function. It takes the number called, it takes an integer. Here it is called as a local variable called n. So I am passing I, so therefore n is here in this function, it is called n. In that function it is called as I. Right? That value is passed. If n equals to 0, I am returning 0. If n equals to 1, I am returning 1. Else it is nothing but Fibonacci of n minus 1. Fib of n minus 1 means this plus fib of n minus 2. So each time I am now getting, first time you are calling one function. Fibonacci of 5, let us say. How do you get it? Fibonacci of 5 is this 0? No. Is n equals to 1? No. Here, Fibonacci of n minus 1 plus n minus 2. N minus 1, it is Fibonacci of n is 5. 5 minus 2 plus 5 minus 1. That is Fibonacci of 3 and 4. How do you get Fibonacci of 3 and 4? Fibonacci of 3 is nothing but Fibonacci of 2 and 1. Similarly, Fibonacci of 4 is nothing but Fibonacci of 3 and 2. So Fibonacci of 1 is nothing but Fibonacci of 0 and 1. So like this you will be adding the previous two numbers and I am getting it. So therefore each time I am getting this. So when you run this program, you will understand how this program behaves by using recursion. Right? Please enter the number of terms in the series. I would like to enter, let us say, 7 numbers. It means please generate 7 Fibonacci numbers. It has not generated. You can see first two numbers are 0 and 1. Next, addition of these two numbers. This is addition of these two numbers. This is nothing but addition of these two numbers. This number is generated, addition of these two. This is generated by using these two addition like this. So it has generated for 8 numbers. It prints. Right? First time when I equal to 0, it says please return 0. So therefore it has to be printed. After that I am putting one T here. I will show you the program. Next, I becomes 1, you are passing this. I becomes 1 means you are returning, there you are asking if I equals to n equals to 0, you are returning 0. If n equals to 1, you are returning 1. So since n equals to 1, so therefore 1 is returned. Next, you are coming to I equals to 0, 1, 2. So 2 it has become. Fibonacci of 2 is nothing but Fibonacci of n minus 2 plus n minus 1. Fib of n minus 2 plus fib of n minus 1. So fib of n minus 2, again you are calling this function. If this is equal to 0, then you are returning 0. Then otherwise it is you are returning 1. So like this still you get this. You will be adding these two numbers and getting this. Similarly for this, you will be adding these two numbers and getting this. So how do we get this? This is nothing but addition of previous two. This is nothing but addition of these two, but first two numbers are 0 and 1. That's why I am returning 0 and 1. So like this, every time it gets added so many number of times. You can appreciate this by writing with different inputs. I will be writing, let us say, 12 numbers. So 12 numbers, you will be getting this. So 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 13 is 34, 34 plus 55 is 89. Like this it keeps on. You can generate for n number, whatever number you wanted. It keeps on adding previous two numbers and getting. But adding previous two numbers, I am taking it from fib series itself. So this is how recursion works, right? Being students of first semester, not to worry too much about recursion. If you are a computer science student, you will be seeing this most often, especially in algorithm classes and especially in data structure classes. But recursion, you should understand that it is calling the function calling by itself, right? Thank you. We will see in the next videos with the arrays.